over
xy.
right. So xy. So now instead of saying xyx, you say rx. No, what? Rx. Now we're in the medical domain. Okay, Rx. So you go to Rx or Cx or, okay? Do it again. Now, as you're doing this, watch out. You know, if you have to watch out. If you already called Ax Z, don't do it again with another variable. So what do I need to do here? XB. And now, in a test, you might. What if I had a BX? It would be dumb to either use XB and new symbol, right? So I would use the BX and I'll say X, whatever. You're allowed to do that, even though the algorithm officially goes left to right. Right? He's not trying to optimize. Okay, but here you will make XB, which we don't have a T. B? Sorry. T goes to XB, right? So this will become Tx. Here I can use the T I introduced, so this becomes Tx. And in XB I already have a Tx. What? Is everything now in Chomsky form? Yeah. This grammar will be equivalent to the original one. Huh? I forgot, yeah. At this point, I can even ask you a question. You can look at it and suppose it says, is E in the language generated, is the empty string in the language generated by this grammar? No. Because if a grammar is Chomsky form, you can look at it and you can answer this question in order 1. All you have to check is if S goes to E. If it doesn't, okay? That's it. On both sides, I guaranteed have 1, 0 here, and I have 0 star here. Right? Or it could be both on that side. And you might have more, not necessarily, but not or more. Did I do all cases? Right. So what's the language? All these strings together with all these strings, that's the union. The language you want is, if we call this L1, this L2, L3, L4. You want an you said an automaton for deterministic or non-deterministic? Deterministic. You want an automaton for this language, right? All the strings with no ones, but at least 2 zeros. Okay? Together with all the strings, like that. You can use the algorithm to find that. Because from a regular expression, I can build a non-deterministic. The algorithm. Okay, I have it. Same for here, same for here, same for here. Then I have 4 non-deterministic ones. Right. Then to do the union, you can do this E business. Then take it and convert it to a deterministic. So that's the first way to do it. That will take you, I don't know, more than half an hour, maybe. It's a long process applying algorithms, right? But that's the first way. If you go algorithmically, you know, that will be a way to do it. Okay. Now, they did not tell you to use algorithms and stuff like that. They said, give me a deterministic automaton for this. So you don't have to go that way. What's another way to do it? Now, another way usually, if they give you a language like that, whatever it is, to solve the problem would be, maybe instead of building an automaton for this language, if I try to build an atom for the complement of this language, and I can do this quickly, then I'll take that and flip the states and I have one for this language. So instead of this language, that's worth exploring. You might say, oh, can I build one for the complement? That would be another approach. Right, that might be faster, you know, without algorithms, without using algorithms. Okay? And of course, the third approach is without using any algorithms at all, use your intuition and say, okay, let's see here, what if I see a 0? How will we be doing in the exercises? Should I stay here or go? Okay. Maybe do a loop. I ignore the zeros. If I see a 1, right? Well, here you cannot ignore the zeros. Well, let's try the second approach. Okay. If the complement of this is as complex as that one, then of course I will not try. But what, just for exercise sake, what's the complement of this? All the strings with at least 2 zeros, if the string violates that, he's not in there. I don't care about the ones, right? Okay, he must have at least 2 zeros. So a string will not be there if he does not have at least 2 zeros, which means he has how many zeros? If he has no zeros, he's not in there. So 1 star, all ones is not in there. Right. Okay. If he has 1 0, he's not in there. Right? Okay, 1 0. Like that. Okay. Or if he has 2 or more ones, I don't care how many zeros he has, he's not in there. Right? So basically, he has to do, oops, he has to do, you're saying A and B. Right? The complement will be A this, B this. Right? Okay. So he does not have 2 zeros, or he does not have at most 1 1. So he has 2 more ones. Okay. So he has 2 ones. And could be anything in here, anything in here. Oh, they don't have to be consecutive, those, right? They don't have to be consecutive. So if he has 2 ones, and in between the ones, he can have anything like that. Right? So that's the complement of that. Now you could do the algorithm again, but you not save much. Instead of 4, I'm doing 3. Yeah. So I will not do it this way either. Okay, if you, the third approach will be try without algorithms, right? You know, to build it. And you can try, again, you can use the trick with the computer. You can try to build this, or you can try to build the complement, whatever is easier for you. Okay. Okay. So I start. What if I see a 0? I cannot stay. I cannot stay and ignore it because I'm counting the zeros. I'm trying to build this. Right? I have to move to another state. I have to count it. What does that mean? I have seen a 0. Okay, I'm looking for at least 2. Right. Okay. What if you see another 0? You cannot stay. You lose track of the count. How many have you seen so far? So at least you're satisfied. Hey, I've seen 2 zeros. Right? What if I see another 0? Look, because you don't care. You already saw your 2 required. I've seen at least 2 zeros. I'm here. What if I see a 1? You cannot stay because if you stay, what? The requirement is at most 1. You can see 10, and then you'll be good. You start going with the zeros. You lose track of how many ones. You cannot stay. I've seen 1 1. Now, what if you see another 1? It should be no good.
Yeah.
So go to another state, and this is a dead end state, correct? Once you go here, you're dead. It's no good. Because he said the most one, this guy already has 2. So I don't care what he has after it. And this should be non-final. Okay. So I'm here. I show you 1 as a first bit. What if I see a 0? Go to this state. Because you want to count this 0. I've seen my... So this state basically says, I've seen 1, 0, right? And I have seen 1, 1. I've seen 1, 0, and at most 1, 1. That's what this means.
In the second node, you have to see if it goes, I mean, if it reads a 1.
Here, yeah. So now what if you see a 1 here? You don't want to go here because you might have come here from here.
Yeah.
So what if you see a 1?
Go to this state.
To which state?
The middle one?
This one?
No.
If you go here, okay, let's see.
Then more zeros.
You see, if you go here,
From the second node.
Then we need 0, 1, 0, 0 to reach the final state, you know. Up.
let's see, it said go here. Why I cannot go here?
Then,
If I see a 1. Oh,
Then
because
another
then
one.
1,
yeah.
I already saw a 1. 0,
Yeah.
1, I should be legal, right? But now with the 0, you might proceed with 2 1s. It's an error, right? So you cannot go here. You have a problem here. When you went here, what's your problem? Right now, if you go here, semantically, this node detects what? If you have at most 1, 1. So this node does the OR. You have 0, 1 or 1, 1. Right? So you don't know exactly how many 1s you have. You're confused right here. Remember, deterministic it has no memory. Once you go, you don't know. If I ask you how many 1s you have, you don't know. You're confused. Right? That's a problem, because you have to know. Then what will you do in that step? How will you go out of this step? If you're confused, how can you determine? It's a deterministic atomic, what to do. You must have total knowledge, you know, once you're in that step. So maybe I should not go here. The mistake is 1 step backwards. I don't want to be confused. Okay? So if you see a 0, let's go here. How about going here? This means I have seen 1, 0 and 0 1s. This means I have seen 1, 0 and 1, 1. I know where I'm at. I have seen no 1s. In both of them, I have seen 1, 0. And either no 1s or 1, 1. I need to know that. I need to distinguish. I can't go there. I need to break it down. Okay? So if you're here, you have seen a 0, 1, 0, no 1s. Okay? And I see a 1. Okay? What should I do? This state or this state? This state?
Yeah. To this state and then.
Yeah,
But if you go to this state, okay, let's see. Okay.
You've seen a 1, you've seen.
Now, in this state, do you know how many zeros you saw? You don't know. It might be
No,
1,
I do
Yeah.
know.
or it might be none.
Oh,
You
I
know what I mean? It might be
already
none.
got
None.
Okay.
So when you see that 0, do you know if you have at least 2 zeros? You don't know. Okay.
But if we move
So I'm
here,
confused here again. Right? So what if you see a 1?
you can go to this, that state.
This state?
Yeah.
Okay, let's say you go here. What do you know about the state? If you ever come here, what does that mean?
There is a 1 1 and a 1
You
0.
show 1 0 and 1 1. The order you don't care, do you?
Yeah. No.
Okay. You show 1 0 1 1. That's clear now. It's deterministic. I know. I've seen one of each. Okay. If you are here, this means you have seen 1 1.
Yeah.
Okay. Now, what if you see a 1?
It's an error.
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 Okay. So where should you go with a 1? To the dead end. What if you see a 0?
Final state.
No.
You have at least 2 zeros. You already know you saw 1 0. That's why you came here, right? So if you see another 0, since you have seen 1, you go to the final. You're good unless you see another 1. But you will take care of this here. So if you see a 0, with the second 0, you say, oh, I satisfy this. I go here. So this state means I have satisfied that, at least 2 zeros. Huh? And at most 1 1, because you can come with 2 zeros this way, or you can come by seeing 1 and 2 zeros that way. Now, so to come here, I either have 2 zeros only, or I have at most 1 1 and 2 zeros. If you see zeros, you're still good, because you have seen the 2 zeros. If you see a 1, dead end, right? No, dead end. I'm sorry. Oh, yeah, because you might have, yeah.
0
yeah.
0 1 does not.
You don't know how many ones you have. The problem is, yeah. Coming this way, you have seen 1 1. But coming this way, so I cannot go here. Can I?
No, yeah.
You need another state. So with a 0, you go here. Okay, in this state, what do I know? I have seen
2 zeros, 2 1s, almost 1 1.
I have
That's
seen
the
2
final
zeros
state.
for sure, and I have seen 1 1.
That's the final state.
So it's a final state as long as I see more zeros, I don't care. But if I see 1 more 1,
It's
dead
an
end.
error state. I think that can connect to
Huh?
the 1. 0 0 0.
Are you talking about this?
Yeah.
Okay, now if I'm here and I see a 1, what should I do?
Just go to the final state.
Just
You know
down.
that it's you process zeros, not 1.
Go to this state, because you have seen
Just 1.
the 1 1. If you only have zeros, you're good. But if you see an extra one, dead. Like that.
It do not accept zeros.
What?
It does not accept all zeros.
No, it should not.
But he must have at least 2 zeros.
It does not accept all zeros, that's correct.
He says he must have, look at the language. Wait, look at here.
At most 1 1. It can have no 1.
He should be able, let's look at the language again. So the question is this the only final state?
No,
No,
the
that
previous
is
one.
not.
This one, because this is only zeros. This is accepted. Okay? It has 0 1. So both of them are final states. As we said before, when we're breaking down, remember, it's this or this or this or this. That's what this is, actually. Right? All zeros goes here. Okay? The 0 0 0 0 0 star. That's 0 0 0 star right here. Okay. Well, that's what we have been doing.
Oh,
from the
yeah.
start of the-
That's right. Yeah.
Okay.
How long is the test?
The test will be 1 hour, but you should comfortably make it in 1 hour, but you will have 1.5. So 7:30 to 9.
Yeah.
But basically, it will be the following. You have if they give you, well, if I give you, I guess, or anybody, if you want to go for it, take a GRE or something, or subject test. This is heavily based on this. You will see a lot of questions in this area, if you want to go for a PhD and stuff. Right? So if they give you a question and they say, okay, here is an NFSA compared to a DFSA, you should know how to do that. So you should know that algorithm. If they they give you a regular expression. Okay, here is A star, B star. Build a non-deterministic FSA for it, you should know how to do that. Okay. If they give you a right linear grammar, S goes to AS or E, whatever, okay, and they ask you, can you build a non-deterministic automaton for it? You should know how to do that. That's easy. It will take you 3 minutes, 2 minutes. If they give you one of those or those, write a grammar that is equivalent to it. You should know that algorithm too. I will not ask you all of this, but you know, I'm giving you the possible question. You should know that algorithm. Now, if they give you an automaton and they ask you what is the corresponding regular expression, that's that RIJK algorithm.
Oh, is it?
Remember those? That?
Yeah.
You don't have to know that because that's recursive algorithm. In a test, if you want to do this by hand, it will take you 1 hour, 1.5 hours. So you don't have to know that. So dots means you don't have to. Okay.
So no questions on RLG?
What?
No need to prepare it?
You say no questions to an RIJK. You will not have to know, I will not give you a question where I say derive the regular expression using the algorithm.
But you might ask
One or two.
But I might ask, here is an FSA, what's the language of it? Well, you will not sit down and spend 1.5 hours doing the algorithm, will you? Hopefully not. Because I did not say do the algorithm, right? But ad hoc, you can answer questions like that. Okay, here is an FSA. Okay. Give a regular expression that describes the language of it. What's the language of it? As an RE.
1
1 star, 0, 0, 1 star. Okay. You have any number of ones, but basically you're saying you must have a bunch of ones, but then you must have a 0. If you don't have a 0, not good. And then anything you want, right? So you can answer this kind of question, but what I'm saying is you will not have to answer it using this algorithm, which means what I give you cannot be 10 states, it will be too complex. But as a ad hoc, you can answer this. Okay. If they give you a context-free grammar, can you find an equivalent PDA to do that, to define the same language? You should know that algorithm. From a grammar to go to a PDA. Now the inverse, here is a PDA. Build a context-free grammar that defines the same language. You don't have to know that. That's again computationally intensive algorithm, remember?
Yeah.
Okay. So the other way, you don't need to know that. You will not be asked that. Yeah, from the grammar to PDA, I might have a question like that. Okay. Also, in terms of algorithms, if they give you a context-free grammar and they say, can you convert it to Chomsky form, normal form? Yes, you need to know that. Okay. Also, I can give you a language described in a natural language. I'll give you a collection of strings described as all strings that start with A and end with B, where the alphabet is A, B, C. Now, given a language like that, described as in natural language, given the description of the strings, I can ask you, okay, build, I can ask you many questions. Here's the first type of question. Build an FSA for it. And I can say non-deterministic or deterministic. You should be able to do that. And usually ad hoc, you know, state, go, loop. Yeah. Or I can ask you, it might not be regular, right? So I might ask you to build a PDA for it. So be able to build a PDA. I see an A, I push on the stack. I see a B, I switch to another state. Right? This is ad hoc again. Or the third type of question, I'll say, if it's regular, build an FSA for it. So you will have to decide if it's regular or not. I will not tell you. Right? If it's not regular, if it's context free, if it's not regular but it is context free, because some languages are not even that. If it's context free, then build a PDA for it. So then you have to make a decision and build the corresponding. If it's context free and not regular. Otherwise, even if it's regular, if I phrase it like that, you can just put it every regular reason. So this kind of problem. Or I might say, what? Wait. No. Or I might say, okay, here's a language, all strings that start with A and finish with B in the alphabet ABC.